Part A, we are given the log equation 2 ln x plus 1 plus ln x equals ln x plus 9. And we need to show that this equation can be written as x equals square root of 9 over x plus 2. On the left side, there are two long terms, so we need to group them together, and we need to use the power law so that that 2 can be moved back to be the exponent of x plus 1. Applying the power law, we have ln of the square of x plus 1 plus ln x, that is ln of x plus 9. Using the product law, we can write this as ln of x times the square of x plus 1, and that is ln of x plus 9. Taking anti-log, we have x plus 1 square equals x plus 9. On the left, the square of x plus 1 can be written as x squared plus 2x plus 1. And we can expand that to obtain x cubed plus 2x squared plus x equals x plus 9. There are two x terms that cancel off, so that x cubed plus 2x squared equals 9. We can factor x squared, and we have x plus 2 in the bracket. Dividing throughout by x plus 2, x squared is 9 over x plus 2. Taking square roots, x is plus minus square root of 9 over x plus 2. They are plus minus, so there are two values of x. One is positive, one is negative. But we have ln x here, meaning that x must be positive. Then we just take the positive square root. We have x equals 9 over x plus 2, since x must be positive. Part B. We are given the equation x equals to square root of 9 over x plus 2 has a single root. And we need to show that this root lies between 1.5 and 2.0. Rearranging that equation, we can write as x minus square root of 9 over x plus 2 equals 0. Then we let fx to be x minus square root of 9 over x plus 2. F at 1.5 is 1.5 minus square root of 9 over 1.5 plus 2. That gives us a value of negative 0.104, which is less than 0. F of 2.0 is 2.0 minus square root of 9 over 2.0 plus 2, which is 0.5, and this is greater than 0. We say that f at 1.5 is less than 0, and f at 2.0 is greater than 0, meaning that fx has a 0 between 1.5 and 2.0. There is a change in sign that you can see here. That means x, which is square root of 9 over x plus 2, has a root between 1.5 and 2.0. Part C, use an iterative formula based on the equation in part B to find the root correct to 3 significant figures. The result of each iteration must be to 5 significant figures. From part B, we know that x is square root of 9 over x plus 2. So we can write this as x of n plus 1 equals x square root of 9 over x sub n plus 2. And we can let x naught to be 1.5. From the previous part, we can see that f at 1.5 is closer to 0 than f at 2. So we start with 1.5 in order to converge quickly. We do not want to repeat this countless times. It's painful. X sub 1 would be square root of 9 over 1.5 plus 2, and that gives us a value of 1.6036. Well, this is very different from 1.5. Then x sub 2, we have square root of 9. Now the x is 1.6036 plus 2, and that gives us a value of 1.5803. X sub 3, we need it to converge to 3 significant figures. We are nowhere near convergence, so we are 2 plus that in the denominator, which is 3.5803. That is 1.5855. X sub 4 is 9 over 3.5855, and that is 1.5845. We have not reached convergence to 3 significant figures yet. So x sub 5, and this is square root of 9 over 3.5845, which is 1.5846. So both agrees to 1.58. We need to do another one. If the three of them agrees to 1.58, then we are good. So 9 over 3.5846, that is 1.5845. Now x sub 4, x sub 5, x sub 6, they both converges to 1.58 to 3 significant figures. Then in that case, we say that the root is 1.58.